difference between local and state contractor licenses is significant. A local license is issued by a local municipality, such as a city or county. It typically requires passing a local exam and meeting local code requirements. Importantly, a local license may only be valid within the specific jurisdiction that issued it. In contrast, a state license is issued by the state's licensing board. It typically requires passing a state exam and meeting state code requirements. A key advantage of a state license is that it is valid throughout the entire state. For preparing for the Master's Contractor's exam, particularly in Florida, several courses are highly recommended. One such course is the Florida Construction Licensing Exam Prep course. This course is offered by Florida Construction Licensing Schools, also known as FCLS, and other approved providers. This type of course is beneficial because it covers both the business and technical aspects of the exam, providing a comprehensive review. Another valuable program is the Certified Construction Business Manager, or CCBM program. This program is offered by the Florida Home Builders Association, or FHBA. It primarily focuses on the business aspects of construction contracting, which is crucial for managing a successful contracting business. Understanding the distinction between being registered and certified is also important. Registered refers to individuals who have met the minimum requirements to practice in a particular trade or profession. These individuals may be licensed or certified by a regulatory body, indicating they have fulfilled basic operational standards. On the other hand, certified refers to individuals who have demonstrated specific skills and knowledge through a certification process. This often requires passing a certification exam and meeting ongoing requirements, showing a higher level of expertise in a specialized area. For the Master's Contractor's exam in Florida, it is highly recommended that you obtain a registered license through the state licensing board. This type of license will provide you with the necessary credentials to operate as a master contractor within the state, ensuring you meet all legal and professional standards. For additional information and resources, the website of the Florida Department of Business and Professional Regulation, or DBPR, is an excellent resource. You can find more details at the website address. Navigating the licensing process can involve several technical aspects. Understanding electrical systems is crucial, and that starts with the basics of voltage, amperage, and resistance, which are interconnected by Ohm's law. Ohm's law states that voltage equals current times resistance. This fundamental relationship helps in analyzing circuits and ensuring proper wiring. In practical applications, conductors must be properly sized to carry the intended current without overheating. The National Electrical Code, or NEC, provides tables such as NEC Table 310.15 that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. For example, a 12 American wire gauge, or AUG, copper conductor with THHN insulation may be rated for 20 amps in certain conditions, while a larger 10 AWG conductor of the same type may be rated for 30 amps. Selecting the correct conductor size is essential for safety and preventing fire hazards. Overcurrent protection devices, like circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. These devices are rated in amps and must be selected based on the ampacity of the conductors they are protecting. The NEC requires that the overcurrent protection device rating does not exceed the conductor's ampacity. For instance, if a circuit uses 14 AWG copper conductors rated for 15 amps, the circuit breaker should be rated at 15 amps or less. Grounding is another critical aspect of electrical systems. The purpose of grounding is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. Grounding systems typically involve grounding electrodes, such as ground rods or metal water pipes, connected to the electrical panel. The grounding electrode conductor must be sized according to NEC Table 250.66, which depends on the size of the service entrance conductors. Bonding is also essential to ensure that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. Bonding conductors are used to connect metal enclosures, conduits, and equipment to the grounding system. The size of the bonding conductors is determined by NEC Table 250.102 based on the size of the circuit conductors. Understanding voltage drop is also crucial, especially in long circuit runs. Voltage drop occurs when the voltage at the end of a circuit is less than the voltage at the source due to the resistance of the conductors. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Calculating voltage drop involves using Ohm's law and considering the conductor length, current, and resistance. Using larger conductors can reduce voltage drop. Electrical panels are distribution points where power is supplied to various circuits. Panels must be properly sized to accommodate the connected loads. The NEC requires a load calculation to determine the total demand on the panel. This calculation takes into account the connected loads, demand factors, and diversity factors. The panel's main breaker must be rated to handle the calculated load. Different types of electrical systems exist, such as single-phase and three-phase systems. Single-phase systems are commonly used in residential applications and typically operate at 120 volts or 240 volts. Three-phase systems are used in commercial and industrial applications and can operate at voltages such as 208 volts, 277 volts, or 480 volts. Three-phase systems are more efficient for large power loads. Conduit is used to protect conductors from physical damage and environmental factors. Different types of conduit are available, such as rigid metal conduit, or RMC, electrical metallic tubing, or IMT, and flexible metal conduit. Each type has its own advantages and disadvantages in terms of cost, installation, and protection. Hazardous locations require special wiring methods and equipment to prevent explosions and fires. The NEC classifies hazardous locations based on the type of hazardous material present, such as flammable gases, vapors, or dust. Equipment used in hazardous locations must be approved for the specific class and division of the location. Lighting is a significant part of electrical systems. Different types of lighting fixtures are available, such as incandescent, fluorescent, and light-emitting diode, or LED, fixtures. LED fixtures are becoming increasingly popular due to their energy efficiency and long lifespan. The NEC provides requirements for lighting installations, including the spacing of luminaires and the control of lighting circuits. Motor circuits require special considerations due to the high inrush current when starting motors. The NEC provides specific requirements for motor circuit conductors, overcurrent protection, and motor controllers. Motor starters are used to limit the inrush current and provide overload protection for the motor. Transformers are used to step up or step down voltage levels. They are essential components in electrical distribution systems. Transformers must be properly sized and protected with overcurrent devices. The NEC provides requirements for transformer installations, including ventilation and grounding. Renewable energy systems, such as solar photovoltaic and wind power systems, are becoming increasingly common. These systems require specialized wiring methods and equipment. The NEC provides requirements for the installation of renewable energy systems, including grounding, overcurrent protection, and disconnects. Inspections are an important part of the electrical installation process. Electrical inspections are performed by qualified inspectors to ensure that the installation complies with the NEC and local codes. Passing an electrical inspection is essential for obtaining an occupancy permit. Understanding the NEC is critical for electrical contractors and installers. The NEC is updated every 3 years and provides the latest requirements for safe electrical installations. Continuing education is essential for staying up to date with the NEC and new technologies. When working with electrical systems, safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of circuits. Only qualified and trained individuals should work on electrical systems. If you are not comfortable working on electrical systems, hire a licensed electrician. Proper planning is essential for successful electrical installations. Develop a detailed plan that includes the location of outlets, lighting fixtures, and equipment. Obtain the necessary permits before starting work. Follow the NEC and local codes. Test the installation thoroughly after completion. Electrical troubleshooting involves identifying and resolving electrical problems. Common electrical problems include open circuits, short circuits, and ground faults. Using a multimeter can help diagnose electrical problems. Always follow safety precautions when troubleshooting electrical systems. Remember that safety is always the most important aspect of electrical work.